Welcome back to Hoochos.
Today on Hoochos, I'll be running you through a guide on 3D printing, upgrades for your 3D printer, troubleshooting, and my print settings for the prints available on my channel.
So I've had a ton of requests for this video, and I want to summarize the things that I've learned over my 3D printing journey for the last couple of years, culminating in my purchase of a CR30 and the 4 machines you see behind me, as well as the direction of this channel with 3D printable hydroponic parts to enable people to hyperlocally manufacture their parts for growing their own food. In this guide, I'm going to start general and then end specific. So I will end with all of my print settings for the 0.8mm nozzle that I use with the material PETG on all of the hydroponic system parts that are available on other videos on this channel. Now, for those who haven't already jumped into the 3D printing space, you need to understand that in 3D printing, things go wrong. But it is the most challenging as well as rewarding hobby that I have undertaken up there with hydroponics. Understanding this, we need to tailor our choice of printer to the fact that we are foreseeing that some things can go wrong, and we want to make that scenario the least hassle possible. So with that in mind, we're going to choose a printer that is numerous as well as open source. My choice for printer was the Ender 3 Pros. The reason being they are so numerous and all parts are open source and readily available on all major online stores. A lot of the parts are actually going to be available locally as well from places like hydraulics and pneumatics stores for all of the bone tubing and the connectors, as well as the fact that there's going to be plentiful guides and reviews available to you so that you can make the most informed decisions when troubleshooting or modifying the printer. This community input has also made them extremely customizable with third-party mods, allowing you a range of different directions within your style of printing. So let's start at the beginning. The first upgrades that you're going to want to complete on these machines, and the ones that I think that they should immediately come with out of the box, are you're going to want an all-metal feeder. Here I have an almost stock Ender 3 Pro. The only thing that's not stock about this Ender 3 Pro is the filament end sensor. So here we have a plastic filament feeder, and with these plastic filament feeders, they tend to break extremely easily. And if they don't break, they warp in such a way that they do not put enough pressure on the stepper motor that feeds the filament, and it causes the filament to slide and the prints to fail. Here I have an example of one of my plastic filament feeders that has snapped and let go of this piece here, and this has caused a fairly long print to fail. I've also had multiple issues where you cannot get this tight enough because the plastic is warped and it causes slippage in the line and causes not complete fails, but artifacts within the prints. Number 2 on the list of upgrades is Capricorn tubing. The blue Capricorn tubing is a higher temperature PTFE tubing than the stock Bowen tubing that comes with the Ender 3 Pro. This means that it's going to withstand the higher temperatures that you throw at it, especially when you are printing in PETG like I am, and it reduces the likelihood of the tubing melting in the hot end and causing print fails. So this is an upgrade that I do highly recommend. Third and final immediate upgrade is the springs. Springs that come with the Ender 3 Pro are these silver light duty springs, and they do work, but these yellow replacement springs, these are Leeway 20mm springs, make sure you get the 20mm springs for the Ender 3 Pro, because the 25mm springs do not work. They compress too far and end up over compressing, and this will just reduce the amount of times that you need to bed level. Now, all these upgrades I think should come with the printer. It would not cost Creality any significant amount of money more to supply them with the printer, and it would reduce a ton of heartache for their customers, but this is the world we live in. So again, straight off the bat, you're probably going to want to invest in some spares for your printer as well, because when you are troubleshooting problems, you will encounter things that fail that you don't want to be waiting 2 weeks postage on, especially when you have multiple parts fail and you find out that thing that you're troubleshooting isn't the problem. I would recommend having some extra Capricorn tubing, and to connect that to the printer, you're going to want some of these. These are PC4 to M10 pneumatic tubing connectors. Essentially, they connect the Bowen tubing, which is 4mm pneumatic tubing, to the filament feeder as well as the hot end. Unfortunately, and this is a bit silly, but the printer comes with a PC4 to M6 on the filament feed. Probably going to end up taking this whole printer apart by the end of this, but anyway, I'll show you. This is the stock filament feeder, and you can see it comes with a PC4 to M6 for the feeder, and on the hot end it actually has an M10 to PC4, so you're stuck buying two different connectors if you stay with the plastic filament feeder, which is just ridiculous. I don't want twice as many parts. So when you upgrade the plastic filament feeder to the aluminium filament feeder, it actually comes with an M10, which means that you can just use one single PC4 connector for both of those fail points on your printer. When buying these, I highly recommend buying a quality PC4 connector. And to do that, you should go to a physical hydraulic store within your area. As long as you know that it's a PC4 to M10 connector, you can go to a hydraulics or pneumatics store. Just type it into Google, it'll come up, and buy decent quality hydraulic and pneumatic PC4 connectors. And you can kind of tell because it'll have this humming tape around it, and that is a good quality connector. And that is where I got my PC4 connectors. So the next thing you're going to want spares of is nozzles. Now, it's obviously going to depend on the type of nozzle you're using. I use predominantly 0.8mm nozzles, and the reason I use these is for speed of print. It basically halves the time that you're printing, but it does require you to calibrate your printer for that specific nozzle. So just quickly, for the people that don't get to the end of the video, I increase my retraction settings from 6.5mm retraction to 10mm retraction. This is on PETG. The speed is at 25mm per second. I also reduce the recommended speed of infill from 50mm per second to 25mm per second. And that matches the speed of the infill with the speed of the rest of the print. And that is because the stock hot end on the Ender 3 Pro is not hot enough to keep up with extrusion of PETG at 50mm a second through a 0.8mm nozzle, because there's just so much material being moved through that nozzle, as far as I can tell. In the summer months, I can get away with it because the ambient temperature is up, but I cannot get away with it in the winter months. Okay, so let's have a look at the optional upgrades that you can perform on your Ender 3 Pro. These are essentially upgrades that will make life easier, as well as save filament and money essentially. So the first thing is obviously going to be the filament end sensor. This is going to allow you to print right to the end of a roll of filament. This is, however, not foolproof, as sometimes I find that filament rolls can actually hang on to the filament and cause the print to fail, because obviously the filament can't get pulled through because there's too much tension on the filament. So filament end sensor is a very good addition, but it is not foolproof. The second addition is the BL Touch or CR Touch, which is this device here. This is specifically the CR Touch. And on this printer you can see I've got the BL Touch. This is just the newer version that looks a little bit nicer. This is actually going to allow your printer to sense the bed level. It will take measurements of the bed level every time you print, and it will adjust the print nozzle height according to where it is on the bed as the device prints. So it's going to reduce the amount you're needing to bed level to once every 6 months or so, given that you have sturdy springs on your bed. Both of these devices are going to require an upgrade in your firmware to work, and they're also going to require that you pull the bottom off your printer and do some work inside of it. We'll talk about opening up the printer in a second, but first of all, I want to talk about firmware. These printers are running the Marlin Bug Fix 2.0.x Marlin firmware. Now, the benefit of this firmware is that it gives you multiple different configuration options that you do not get from the original firmware. In configuration, you actually have multiple advanced settings, probe Z offset, BL touch on and off retraction, your run out sensor, your power outage options, and all of the standard default options. So in our advanced settings is the thing that we actually are going to like the most. We can probe our offsets for our BL touch, and it provides a Z probe wizard which allows us to actually probe the height of the bed so that the BL touch can work. Now, the thing that no one ever tells you is that once you've done your Z probe, which is your height probe, you then have to go back out and store the settings, and this will actually save all the settings within the Ender 3 Pro. Whenever you change settings on your printer, make sure that you store the settings, because I could not find any information anywhere of people actually recommending that you store the settings. I highly recommend this firmware, and it has solved a bunch of issues for me. So I'll provide a link in the description for where you can get that firmware, and all you have to do is update your printer by loading the firmware onto your SD card into the printer and turning it on. So this brings me to the next part of the video, and I want to discuss people's hesitancy to actually open up a device and go inside. So I want to encourage you to become familiar with the internals of this device, because inevitably you will be digging around inside, and it's not a void of warranty or anything, because these are made to be upgraded. They're made to be tinkered with, and I highly recommend that you don't deal with Creality for warranties. So I want you to know that there's absolutely nothing to be afraid of inside of this device. There is no soldering, everything is plug and play, and the things that don't have plugs are bare wires that have a screw fix that you unscrew and slot the wire into. Most everything is color coded, and the socks around the cords can be retracted so that you can easily put wires in and out of them when you're replacing parts on the printer. Everything is zip tied with small zip ties, so that's probably something you'll want to have lying around as well. But let's have a look inside, and I want to show you something that you need to know about your printer. So when you're actually setting up the printer, you will have to do a little bit of connecting of wires and stuff, and the initial setup can be daunting. But I would recommend that while you're connecting up those wires, you open up this bottom part and have a look inside and take a couple of notes. Now, the reason I recommend doing this is because in the future, if there are any problems or you want to add features like the CR touch or the filament end sensor, you need to be aware of the motherboard that's inside your printer. So if we have a look in here on the middle of the board, right there, we have a motherboard version. And my version is version 4.2.2. Now, knowing this version is important because the BL Touch and the CR Touch are going to require different wiring for different motherboards. Also, the Marlin firmware will be different for different versions of the motherboards as well. There's 3 versions as of the filming of this video. This is the middle version, and I've been lucky enough that all my printers are the 4.2.2. Now, while you're in here, take a look at all the wiring and where it leads to. Do not be afraid of it. You can just follow the colors back to where they go. Take photos of its existing state when you open up the motherboard. Make sure you put all of your screws in an orientation that makes sense, putting it back together, and follow guides that help you set up the devices using the proper guides with the proper motherboard and your printer model. It's really not hard, but it can seem daunting at first. I've pulled this apart so many times now that I don't even need to look at which screws are which and where the cords go. Okay, so the next thing I want to talk about is troubleshooting. Logically moving down through scenarios that could be causing the problem that is facing you. Always the first thing that you want to check when troubleshooting is the printer construction. You want to check it for malfunction or looseness. So you want to be checking the gantry to make sure that there's no movement. You want to be checking the head to make sure that it's moving properly, and also the bed to make sure that it is also moving properly. You want to check that all of the motors are working, the stepper motors, and also that your filament feed is working and extruding properly. Now, that brings me to the first scenario that you might face, and that is a clogged nozzle. Now, there may be a multitude of reasons for a clogged nozzle. It can occur from settings being wrong, like the nozzle temperature being too cold for the material that you are printing. It can be a hot end failure or a temperature sensor failure. Could be that the Bowen tube itself has melted within the hot end of the printer. It could also be that there is particulate in the filament that has caused the clog itself. Generally, it is the former, and it will be a nozzle hot end clog, and the filament has blocked up the extruder. Now, to get rid of something like this, you would preheat the hot end. So for myself, I'm using PETG. So I'm going to be preheating the nozzle to 230 degrees. I usually run it at 215, even though my PETG is actually rated for 220 to 240, but we'll talk about print settings later. So I'm going to preheat that nozzle to 230 degrees. I'm going to unhook the Bowen tubing from both sides. So to do that, I'm just going to pull out the filament and the Bowen tubing. And this is going to allow us to physically retract the filament out of our hot end once it's heated up. So we'll wait for that to heat up. This is another problem that always irks me. 3D printer hairs get into the fan, and they are the most likely cause of a fan failure. There are prints that you can get that cover these fans and cause them to draw in air from the top rather than the front, because most of these are super fine, these 3D filament hairs. Look how fine they are. And they just get caught around the axle of the fan and cause the fans to burn out or stop. The other thing that always tends to happen to me, and it stopped happening because I've learned, is that I used to try and get the hairs out with pliers and stuff, and I'd do it while the fan was running, and if you so much as touch one of those blades while it's spinning, it will break. Do not stick anything into this fan enclosure. Wait until the fan's off before you try and remove something like a 3D print hair, and look online for prints to cover this fan. Okay, so we're at 230 degrees. I'm now going to remove the hot end part of the Bowen tubing. So we'll push that down. We can now pull through our filament, and that gives us access to remove this PC4 to M10 fitting. And now we have access to the top of the hot end, and from the bottom of the hot end, I'm going to remove the protective black silicone cover, and we're going to unscrew our nozzle, like so. And we're going to try and make sure that it's not on anything that it can burn. So while we're here, I'm actually going to show you the type of nozzle that I would recommend getting. I really like these nozzles, but they are rather expensive. So the nozzles that come with the printers are generally, these brass nozzles. It'll come with a 0.4 millimeter nozzle, but these are the nozzles that I've been using lately. They are the Bondtech MOS CHT nozzle. And as you can see from the top of the nozzle, they are completely different. These Bondtechs give a ton more surface area for the filament to melt in, and this is extremely beneficial, especially when you're using larger extrusions like the 0.8 millimeter nozzles. So now that we've removed both ends of the hot end, there is a large cavity that we can clear out. So to clear it out, I usually just use one of the Allen keys that come with it, and we can just run our Allen key straight through the head. You can use larger Allen keys because there is a ton of room, and that will allow you to clear out clogs within your hot end. Now, another problem that I've come across semi-regularly is Bowen tube ejection. Now, this comes from cheap PC4 connectors, and the internals of the PC4 connector will disintegrate and cause the Bowen tube to eject. And what happens when that Bowen tube ejects is the Bowen tube is actually keeping tension on the filament feed going from the filament feeder all the way through into the hot end. So this is where direct drive extruders come in and their benefits. However, with this style Bowen tube extruder, if this problem happens, the Bowen tube will eject and the filament feed will continue feeding, and you'll end up with a hot mess of filament spaghetti. The print will stop, the head will continue moving, and there will be no filament ejected through the head. This can actually cause your Bowen tube to melt internally if it's not a Capricorn tubing, because there is no filament being pushed through, it's just directing all the heat into the Bowen's tube. The printer will continue to print in its normal way. It will just follow the G code until the end. You will not get a filament run out error and you'll end up with a hot mess of spaghetti. This has actually caused me some major problems in the past when this happened, and the filament got entangled with the printer and caused a ton of problems on a perfectly running print, on what was a perfectly running printer. So this is why I would recommend getting good quality PC4 connectors, because they are the only thing between your printer and a catastrophic failure in a print. And also use your little blue stoppers. Now this next problem is probably one of the most common problems, and it's really hard to diagnose because it could be an array of issues. So slipping on the filament stepper. Slipping on the stepper can be caused by a heap of physical things as well as the settings that you input into the printer not being compatible with the physical capabilities of the printer itself. So the physical things that could be caused are a clog where the filament literally cannot pass through the hot end. Could be temperature, where the temperature of the hot end isn't hot enough to feed the filament fast enough, so the filament feeder becomes the weakest link and begins to slip because it can't feed the filament fast enough because the filament isn't melting fast enough. Another thing that can cause this is Bowen tube restriction. So if the Bowen tube heats up and shrinks, or alternatively, if the filament is getting fed too fast and backs up, the heat can actually back up the filament, causing the filament to compress and thicken, and then that will then cascade back to the filament feeder, because not only is the filament pushing too fast and not melting fast enough, but now it's also got to deal with the fact that the filament is rubbing against the Bowen tube, causing friction and slowing the filament down even more. And then you have that catastrophic cascade of a bad time. It can also be caused by the head of the printer being too close to the bed, or the ambient temperature in the room that it's in being too cold and not allowing that filament to melt fast enough and causing all of those problems. It can also be settings like the temperature, the feed speed, and also the nozzle settings, like whether you're using a really small nozzle or a really large nozzle. The last of the physical troubleshooting I want to cover, because there's so many topics, but these are the main ones, is the catastrophic hot end malfunction. And unfortunately, I've had two of these where the hot end heater and the Bowen tube acceptor has separated, and the print itself becomes a giant blob extruding out of the front of your hot end. Generally, this will require a hot end replacement, and that will require you cutting all of your zip ties, pulling the sock back over the wiring that heads back down into your motherboard. You will need to purchase a replacement hot end, reconnect the hot end in the places that the old one was connected. Now, it will require you to purchase a hot end that is of the same voltage as your printer, so make sure you take a note of the voltage of the hot end. But if this happens, don't be afraid, there are a ton of guides. All you really need to do is take photos, take note of where the hot end is right now, how it is connected, how the wires are run back down. Make sure the hot end you buy has the right length of wire. Generally, you will be able to search for the printer, the voltage, and by making sure that it's the same part, you should be able to replace it fairly easily. Unfortunately for me, this has happened a couple of times, but it's not really surprising with the amount that I print. And it is quite daunting when you first take on the task. You will get to the end of it and you'll be back printing, and it will be a rewarding exercise in the end. Okay, so now I want to talk about print troubleshooting. Now, there are a variety of reasons that prints can fail, but the main reason that no one ever talks about for beginners is the filament being wet. Checking that your filament is dry is going to fix a majority of the problems that people face with print failures. The reason that this is a bad thing when it comes to 3D printing is because the heat with which we are melting the plastic in the hot end is sometimes double the boiling point of water, which will cause bubbles of steam to explode once the plastic leaves the hot end environment. And this causes bubbles within the print itself. It causes defects within the print, and it causes the print surfaces to be visually unpleasant. To combat this problem, I dry my filament before I print. I dry my filament no matter whether the filament is old or new, straight out of the packet because I do not trust filament manufacturers to dry the filament properly. If it's more expensive filament that you're familiar with, you may be able to trust that it's going to be dry. However, I'm using the cheapest PETG I can get my hands on, and at $20 a kilogram, I do not trust that it's dry out of the packet, and regularly I come across filament that is definitely nowhere near usable. The way that we dry filament. Now I use a dehydrator. PETG is meant to be dried at 65 degrees Celsius for a duration of longer than 4 hours. So a dehydrator is a perfect device for drying filament. If you do not have a dehydrator, you can use your oven. However, I'd be very careful and make sure that your oven is registering the right temperature and turning off at that temperature and not going too high. So definitely test whether your oven is capable of holding a low temperature. The other way that I've seen people do it is by placing the filament on their print bed and then heating it up to temperature and leaving it for an extended period. I'm not sure of the wear and tear that this causes on your printer, so I'm not going to recommend that. I've just seen people doing it. The ideal way is a food dehydrator, and it will allow you to set a timer and dial in an exact temperature that you can tailor to your filament. To store the filament from here, I will actually do batches of filament. I'll fill up the dehydrator with new rolls of filament, and then I will batch cook them so that I can then store them in one of these. Now this is an IP rated waterproof storage box which has seals around the top and allows me to keep the filament in an airtight environment. And within this filament storage, I have the water absorbing silica. This makes sure that any moisture that gets in when I open the box is dealt with so that the filament is as dry as possible before I print. So if you don't have any of the previous problems, your filament is dry, your nozzle is at the correct height above the bed, and there's no friction on the filament anywhere through the system. We can now look at our print settings and whether they're right for the printer you're printing with, the filament that you're using, and the item that you're trying to print. Okay, so you're gonna have to excuse the peeping in the background. We saved some chickens that were left outside of the mother's enclosure and almost succumbed to exposure, but that's another story. Those chickens look like this. These chickens were printed with a 0.4 millimeter nozzle, and as you can see, they were printed in yellow PETG. Off we go. So right now we're going to cover my settings. These settings are for PETG. Okay, so obviously the density of the part is going to change dependent on the application of the part. So structural parts will be higher density and non-structural parts will be lower density, but all else generally stays the same unless you're changing supports and other physical attributes like that. For my settings, I use a draft quality because it's a 0.8 millimeter nozzle. Its layer height is 0.032. You can see here all of the other numbers. Our wall thickness is 2.4 millimeters. The wall line count is 3. The reason I use a 0.8 millimeter nozzle is because all of the prints that I've designed for my channel are divisible by 0.8. They're divisible by 0.4 also. There's just twice as many lines. So that is how I've designed most of the prints. Most of the prints are also printed supportless, although I have had one or two where I had to implement supports to get the print to work. This wall count will be applicable across the board with all of my prints. Top and bottom thickness you can change to whatever suits you, but my top and bottom thickness is 1.28 millimeters, and you can see that the top layers is 4. The infill density, as I said, will change. Cubic and gyroid are my 2 favorite styles of infill. It doesn't particularly matter which one you use for my prints, but those 2 I've found the most reliable infill print. The printing temperature for the PETG that I use, which is just a generic cheap PETG, is 215 degrees Celsius. Now on the side of the PETG rolls, it actually says 220 to 240 degrees Celsius. So do not always abide by the manufacturer's recommendations, because I found that they're not always correct. For the PETG that I use, and for most people, because they'll be using the cheapest filament they can get their hands on, the PETG works best at 215 degrees Celsius. If you have it any hotter than this, it tends to string really easily. If you do want to go hotter, it will make the PETG more liquid and you will get somewhat of a cleaner print, but you will have to adjust your retraction up. The speed that I print with for PETG is 25 millimeters per second. To set the 25 millimeters per second speed, you set your print speed to 50 millimeters per second, it fills out the rest, then you change the infill speed, because the print speed being 50 millimeters per second only pertains to the infill speed being 50 millimeters per second. So you'll change that to 25 millimeters per second, and this is to stop the nozzle from clogging up, because it cannot heat the volume of PETG going through the nozzle at that speed. You can see the rest of my speeds there. You can see all my travels there, and you can see all my print cooling there. And for build plate adhesion, I like to use skirt with 3 passes, and that just makes sure that I've got the filament running out of the nozzle before it starts the print. The retraction distance for PETG is between 8 and 10 millimeters. The retraction speed is 25 millimeters per second, and I found this settings to stop stringing, which is a huge problem with the PETG on a 0.8 millimeter nozzle, because there is just so much room for that PETG to melt and string out. I find that stringing is one of my biggest issues running such a large nozzle. So I have to run it cooler than I normally would and slower than I normally would, with a greater retraction to make sure I don't get that stringing. Now, obviously these print settings are extremely niche, and I wanted them to be that way because I'm creating this video for the people on my channel and my Patreon who want to print in the same method that I print. But if you're using different nozzles, different hot ends, different printers, all of these settings will differ. And this is kind of where you can put your own flavor into the 3D prints that you do. And this is where the skill in 3D printing lies. As well as troubleshooting and problem solving, you are going to be identifying the best methods for materials and hardware that you have available to you, and tweaking those in your print settings. And this is essentially the art of 3D printing. This is where you can get the most reward from observation and implementation of reactionary measures to negatives and positives in the environment of the 3D prints that you're printing. This is the fun part. People that are in it for the end product aren't going to enjoy this part, but this is where I found most of my enjoyment in 3D printing, the tinkering with the hardware and the tinkering with the print settings. It's a very worthwhile hobby. It's testing and it will strain your patience, but the rewards are endless. Being able to digitally design something and then physically print it bridges the world of the cyber to reality. And it is phenomenal that this technology exists in our lifetime. Okay, well, I hope you enjoyed this episode of Hoochos. If you want to see more 3D printing episodes, I'd be happy to make them. I am just as obsessed with this hobby as I am with hydroponics. So Leave a comment in the description below if you want me to make more videos. Happy 3D printing, happy hydroponicking, and I'll see you next time on Hoochos.